Yes, hello everyone. My name is Magnus Gedda. I'm also part of Stream Analyze, naturally, and I'm about to show you a demo, basically what Eric has sort of gone through, and I have to keep my fingers crossed here because there's a lot of moving parts in this demo. What we are doing is that we're actually having a couple, or I think it's three, actual edge devices here in the AI Edge Lab that is running, and they will act as our edge devices. So you will have to think of them as our buses that are running around. And we will sort of replay the recorded Kungsbacka data on those devices. So you will see how the buses go around. And so it's a sort of a simulation, but on real data. And it could be replaceable with like real-time campus data by just shifting some small changes to the model. But we'll see here. I'm just gonna see that I have everything set up all correctly, and we can start. So what you see here is SL Studio, the web interface for our platform. And as mentioned, we also have this VS Code plugin, but today we're going to use the web interface. Let's see here. So what we are doing here, we're going to execute some code. In addition to the edge devices, which have been sort of pre-deployed with our software, we also have a server instance running on one of the servers in the Edge Lab as well. And we'll use this server to communicate with these edge devices. So what you see here is the interface for the server. And just to demonstrate that it's running here, we can execute some simple commands. We just do a simple addition. We do some trigonometric computation, some average. And the server also works as a peer in the federation. So the server peer is just referred to as SA. And we'll see, yeah, here we have the edges that are currently connected to the server. They're called W2 through W8. And these are the MX4 edge devices that are in the Edge Lab. Sorry? Zoom a bit. Let's see if I can accomplish that. Is that better? Good. Yeah, hopefully this will fit. Maybe I can that. Yeah, so we can also execute these commands, this query language on the edge devices. So here we execute just hello from this peer ID on the peer W3, and it says hello for me. I can almost imagine the bus driver saying hello from the bus. And so now what we're going to continue with is deploying some models to these edge devices. The first model we'll deploy is just setting up the signal structure. So we go ahead and do that. And in this demo, as I mentioned, we're only going to use the W2, W3, and W4 edge devices. So there will be 3 buses. So now we deploy this model onto the edge devices. And that was pretty straightforward. So now we can ask one of the peers, what actually signals have we set up to read? And it answers with, okay, we have set up these signals. It's the date time, the GPS, engine speed, fuel rate, and so forth. So we have these signals to work with. And then we can just replay one of the signal streams. Let's say we choose the engine speed and replay the engine speed. And you can see here, yeah, the frame rate on the Teams, the frame rate on the Teams screen sharing is not perfect. So it's a bit jumpy, but it flows very well on my screen. But here we can see just the stream data from the engine speed from one of the edge devices. But we can also sort of This stream was just churning out the values as fast as it could, but we can also control the we'll get to that. But first of all, we'll just see the signals that we're going to work with in this demo is the ABS and the latitude and the longitude. So if we look at the data here, it's very difficult to see because the magnitudes are so different. But if we zoom in here, we can see that we have some spikes here in the ABS signals when the ABS is active on the bus. And here we have the time scale playback, where we can control the time scale of the playback. So instead of just churning out the signals as fast as we can, we will replay them in real time because the time factor is 1.0. So we'll just execute that. Oops. Now we lost the connection somehow. Let's see here. Let's see if we're back on track. Yeah, this one is running. So, and as you can see here, let's see, we run this again so it gets even clearer. Yeah, you can see that the data was recorded every other second. So the playback in real time will be one new sort of signal value every other second. But doing a demo, even though you can see that we have some ABS activity here, even in the first part of this data, it will be kind of slow to replay a demo in real time. So we speed it up by approximately 100-fold. So if we do it here, it'll be, yeah, it goes so fast it's impossible to see, but it'll be clear when we do the map overview of this. So in the essence of doing the see, understand, model, automate, we wanted to build this sort of federated model, but we thought that, okay, it's easier to begin with a simpler model. So we thought about doing some rule-based mathematical statistical model. And this is what we have here. So now we're going to deploy a rule-based model down to the edge devices. And the rule-based model simply signals whenever there is an ABS activity on the bus and sends that activity up to the server, like the global model, the server model. So we start by deploying this model down to the buses. So now that, and now we just load some visualization code into the server here. So now we can start plotting the bus positions. And let's see here, I'll just restart the simulation here. Start the Matstat simulation. And if we zoom out, I'll try to make this a bit bigger. Yeah, you can see, oh yeah, the frame rate is quite good. You can see the buses, the GPA position, how they're sort of driving around. And this, as I said, it's the real data. It's not cleaned, so the buses might jump around a bit depending on the GPS readings. And the data speed is sped up by a factor of 100, so they don't drive this fast in in the real world. That would be kind of dangerous. Yeah. So now we have sort of verified that we have visualization of the position. Then we'll just load some more code on the server to plot some more information. So what we have now is that we're using the all the signal information that we get from the buses. And now you can see that the buses are producing like ABS events here, which is sent up to the central model. And the central models is basically just creating an area around this to see that, okay, we're recognizing this area. It's we're having ABS triggering in this area. So we see that the sort of the mathematical statistical rule-based model is working in this regard. So that was the first step. So now we're going to go to the next model and go to the federated model. And to do that, I'll just sort of clear the edge devices and then load the other model here. We have the FedML demo. So in this model, this is the model that Erik showed you, the federated workflow of. Each bus will be running it will be running an unsupervised learning algorithm, a clustering algorithm. So when it breaks a few times, it'll get a few breakpoints, like ABS activity points, and it will cluster those. And if it deems, if the cluster algorithm deems one of the clusters as active, it will sort of transmit the cluster center up to the central server saying, okay, we have a cluster of ABS activity here. This might be important. And then the global model will sort of aggregate all these signals from the edge devices and do a clustering on the global scale as well. So when the global model finds clusters in the transmitted ABS activity from the edge devices, it will sort of create an area which it says, this area might be dangerous, it might be slippery here. So, and it will send geofencing information back to the buses, and the buses will know if they drive into a geofenced area and will be able to act upon that. Maybe signal to the driver that this area is probably slippery where you're at right now, so be careful. So we'll just go through the steps here. We start by deploying the signal structure to the edge devices. So we have the signals to read from, and then we deploy the FedML model to the edge devices. And as you can see here, is based on the dbScan, for those of you who know dbScan. And then we load some visualization information for the server model here. So then we start the visualization and we'll just restart the FedML simulation. Okay, so now you see that, oh, the buses are really fast. They're going really fast now. So they're in the depot down in Kungsbacka, and bus number 3 is already on the way. And you can probably say it might be a bit difficult, but there are some ABS detections, but the global model considers most of them as outliers in the beginning before it gets enough information to determine them to be a complete cluster. And here you can see that we get a heat map of the sort of risky area where the global model has determined that here we have enough ABS activity for it to be a risky area. So what it does is that it creates this geofence and transmits the geofence information down to the buses again. And whenever a bus is inside one of these areas, it notifies the server model that I know that I'm in this area now and I can take action upon that. And the action could be like notifying the driver or something. And so this is basically the model, the federated model in action as you see it, and it's running on these live devices as we speak. And it's sort of a convoluted use case maybe, but the core focus on this demo is not really to create a killer model. It's more about showcasing the capabilities of the infrastructure. So here we have all these moving parts sort of connected, and it's in a working state. And to change this from going from simulated data that is replayed from file on these edge devices to working on real CAN bus data, all we need to do is just basically change a couple of lines of code and maybe add a DBC file to sort of decode the CAN bus, and then it'll run just as well on real in a real setting. Yeah, so this was the live demo part. Let's see, I'll just go to the slide that illustrates what we have been looking at. Yeah, so what did we just see? Let's see. We saw the buses with the ABS monitoring models. We saw them report ABS activity, like the center of these clusters from the clustering algorithms on the edge devices. We saw that the global model determined these high-risk areas by doing some clustering itself. So we were using real edge devices, the MX4s, on real data, and we can easily switch the models to work on directly on the CAN buses instead of just the simulated, the recorded data. And as you saw me deploying the models to the edge devices. It was just one line of code and a key press, and it took a couple of seconds. And within those seconds, the edge devices received the models. It executed the instructions in the query language. It did the query optimization, and it did the compilation of these models. So everything was running in machine code on the edge devices. And the models were not super complex, but they were still unsupervised machine learning models running on the edge devices. And the complete package sort of created a complete federated model, even though a simplistic one, but still a federated model. So. Yes, so that was it. Yes.
So I just had to Google the date, 15th of February, 2012.
Oh, you know what happened then? Or?
Well, it was a cold day.
Oh, it was a cold day.
So I was just curious if you had checked that it was different.
Yeah, we were a bit lucky, I guess, from looking at the data. We saw there was quite a lot of ABS activity, and especially we've talked about like privacy issues, that it was more like market issues. But we can see that one bus was generating quite a lot of ABS incidents right next to the bus stops. So maybe that driver was maybe a bit speed happy. I don't know. So that could be kind of privacy issue as well. So like driver behavior. But that was good. Yeah, I think the data set was very good for this type of use case. Yes.
You have part of your software is running on these MX4s, or is that standard software, whatever the MX4s come with?
No, it's not standard software. It's our platform, SA Engine, has been installed on the MX4s and is running.
And it's also possible to install that on Volvo buses, or?
Yeah.
Okay, so it's just, you could just now go take out one of those buses off the road, install the software, and then have it integrated with this solution.
Yeah, as long as there's an MX4 or a similar sort of hardware.
Okay. And
that would be the next one. Volvo will. Okay.
Okay, yeah, because my question obviously was like how feasible is this to see this in the real world, not just as a demo?
Mm-hmm. So. Yeah, it's very feasible, I would say.
That's absolutely.
Yeah.
Coffee break.
After coffee breaks.
The cliffhanger. It was just thank you very much.
Okay, thank you.